This video is the 7th of a series of tutorials discussing the LX7720 radiation-hardened motor driver for space. First, here's a reminder of what the LX7720 actually is. The LX7720 is a mixed-signal peripheral which works with an FPGA, or a microcontroller, to build a complete closed-loop brushless DC motor controller or stepper motor system. The first two videos outlined the LX7720 at a system level and then dived into a detailed discussion of the half-bridge FET drivers. Videos 3 and 4 introduced the LX7720's 4 current sense amplifiers and showed how to use a current sense amplifier in each of the 3 common current measurement topologies used with motors. Video 5 discussed separating a half-bridge into independent low-side and high-side drivers and how to use current sensing in these cases. Video 6 discussed connecting an LX7720 to brushless DC and permanent magnet synchronous motors. This video will discuss connecting an LX7720 to a bipolar stepper motor. The LX7720 contains 4 half-bridge driver stages and 4 current sense amplifiers, which is enough to drive a 2-phase bipolar stepper motor. Here's a generic 2-phase bipolar stepper motor being driven by 4 half-bridge drivers. The half-bridges operate in pairs to make 2 H-bridges. The LX7720 circuitry is shown simplified, with supplies and decoupling to the current sense and gate drive sections omitted. The key components are the 4 half-bridges and the current sensing. The architecture shown here uses a single current sense per winding, in series with the common ground path for each H-bridge. Each H-bridge has bidirectional current sensing in one of its half-bridge outputs. Current entering one half-bridge from the VMPS motor supply will exit via the other half-bridge, and a positive voltage will develop across the current sense resistor proportional to this current. Since current entering one half-bridge must exit via another half-bridge, only 2 current senses are needed with this current sensing architecture. The half-bridge FETs are shown with their integral body diodes. Diodes in parallel with the FETs are necessary components to carry commutation currents when a half-bridge FET switches off. Commutation current flow after FET switch-off is discussed in the 4th video. The FET body diodes can be paralleled by additional discrete diodes for higher switching speed and lower voltage drop. Motor winding currents normally flow in through a high-side FET from the motor supply VMPS and out to the motor ground M-ground through a low-side FET. Here's current flow one way through a half-bridge, and here's the alternative current flow. An alternative current sensing architecture relocates the current sensing to be at one side of each H-bridge's drive output. Again, since current entering one half-bridge must exit via another half-bridge, only 2 current senses are needed. However, including the additional current sense circuits provides redundancy if required. The current sensing is now bidirectional, depending on whether the half-bridge with the current sense is sourcing current or sinking current. In this example, the top left half-bridge is sinking current, so the current sense amplifier sees a positive voltage proportional to winding current. The bottom left half-bridge is sourcing current, so its current sense amplifier sees a negative voltage proportional to winding current. The LX7720 uses 2 internal ground domains, shown as the signal ground S-ground and the motor ground M-ground. S-ground is used for the digital and analog signals, the control circuitry. M-ground is used for circuitry associated with the external half-bridges, the FET drives, current sensing, and the motor load itself. Level shifters manage the crossing of the ground domains. In most applications, the 2 grounds, S-ground and M-ground, are joined together directly on the PCB. The 6th video discusses the ground domains in detail. particularly for high-power motor designs where the power switching components are on a separate module, or PCB. As a final note, synchronous motors are also available with more than the two-phase windings demonstrated here. Since the half-bridge and current sense stages are independent within an LX7720, multiple LX7720s can be used together to control motors with more than two phases.